Hi, welcome back to our lecture on DevOps practices. The first component of DevOps that I want to talk about is culture. And I think it's the most important component of DevOps. And oftentimes it's the component that people talk about the least frequently. I think it's very easy in our organizations to, focus on more of the technical aspects of DevOps, to focus on DevOps tools or focus on processes. And culture oftentimes kind of gets lost in all of those discussions. But the reality is that culture is so incredibly important. And if you're an organization that is just beginning to embark on its DevOps journey, getting the culture right is probably the hardest thing you have to do, but perhaps the most important thing that you need to focus on. I like this image because I of this bridge, the two sections of this bridge coming together, because I think it helps to sort of represent the sort of two main sort of teams within IT that are oftentimes at odds, and that's the development team and the operations team. Again, because these two teams have different concerns, different measures of success oftentimes, and there's this natural wall that forms between the two teams as code is thrown over the wall by developers, and the operations team has to figure out how to support that code in a production environment. DevOps is all about trying to create this culture which bridges those two teams and it creates an environment where everybody can focus on improving service delivery. So when you think about a DevOps culture, there's a number of priorities that we focus on. We try to create a culture which is very collaborative. And this idea is that teams become multidisciplined. Teams are really focused on service delivery. Traditionally, our development teams might be just focused on writing code. They're or fixing bugs, adding new features, completing stories. But those teams maybe weren't all that involved in the operational aspect of the services. Well, in a DevOps organization, those developers are responsible. They're accountable for service delivery. And so while they might spend most of their time writing code, they're also involved in operations to a great extent. And vice versa. You'll see that the operations team is also involved in the development process. It's a collaborative process. In a DevOps organization, we value transparency. People share information with one another. We try to create what's called a blameless environment. When we experience problems in the operation of our service, we try to figure out what the root cause of that problem is without blaming people. People are going to make mistakes, but the question is, why did somebody make a mistake? Maybe it was a problem with the tooling that they were using. Maybe it was a problem with the documentation. Maybe we didn't provide a person with enough training. We try to, instead of blaming people, we blame processes, we blame documentation, and we try to figure out solutions to solve problems. DevOps organizations are naturally change oriented. As a developer, as an operations person, as a member of the IT team, you learn to embrace and expect change. Change is going to happen. Change is going to happen frequently, and you need to get used to it. You need to embrace it. Developing this sort of DevOps culture, a culture which is collaborative, which is transparent, and which embraces change, is very, very difficult. It's difficult because organizations are siloed, there are entrenched interests. People at times will hide information from one another. Sometimes people aren't collaborative by nature. And as human beings, oftentimes we fear changes. So, learning to embrace all of these cultural priorities is really hard, really difficult. It's easy to go out and buy and install a tool and start implementing a tool. That's the easy part. Getting people to change and getting and winning over the hearts and minds of fellow team members is very, very difficult. So, how do you know if your organization has a DevOps culture? Well, when I'm working with an organization, I look for certain sort of cultural practices. I look to see if the developers and operations team members are, are they interacting with one another? Do they physically sit close to one another? Do they go out to lunch together? Do they go out to happy hour and grab a drink together? I've worked with several organizations where the development teams and the operations teams were located on different floors of the building. Or if they were on the same floor of the building, they were completely separated from one another. And we used to say that developers and operations people are just wired differently. You have to sort of hire different types of engineers for each role. And there can be differences. I mean, there are certain people I think that can really thrive in the operation environment, and there are other people that really thrive in doing more sort of heads down development. The reality, though, is that today in a DevOps organization, we're trying to promote collaboration between these two teams. When I look at organizations and I attend the different development and operations teams meetings, I look to see if operations people are regularly attending the different ceremonies within the development organization. So are the operations people attending the daily development stand-ups? Are they going to the reviews and retrospectives? Are they going to the development showcase meetings? And vice versa. Are the developers going to the operations stand-ups? It's pretty rare that you'll see this sort of interaction. It's pretty rare that you'll see an operations person attending the development meetings on a regular basis. Do the development team members rotate through the operations team? In other words, when we bring on new engineers into our organization, do we give them exposure to all of the different parts of of our IT team? Do they have exposure to both the development side and the operations side, the quality assurance, and so on? Are we sort of rotating them through these different roles? I would guess that if you ask these questions and if you thought about your own organization, the answer to most of these questions is probably no. Well, the goal of DevOps, the culture that we're trying to create, is to change the answer to all of these questions to yes. We're trying to create an environment where the developers and operations people are truly collaborating and interacting with one another. So, in order to understand many of the sort of components of DevOps culture, this idea of, of collaboration and transparency and a blameless environment, you have to understand that that this DevOps culture is heavily influenced by practices that originated with the lean community. And if you're not familiar with lean, well, if you have a manufacturing background, you're probably very familiar with lean because lean is a widespread methodology that you'll find in manufacturing organizations around the world. Oftentimes, you'll hear lean sort of codified as a set of Six Sigma practices. The idea being that the lean methodology is used to improve the quality of the products being produced by the manufacturer. Lean manufacturing originated out of Toyota in Japan, and its purpose was to improve manufacturing quality, and it did that in a number of different ways. If it was a set of practices which focused on eliminating waste within systems. This was called Muda. So the idea is that you'd look at each of your processes and you'd try to figure out which steps in those processes were unnecessary or could be reduced in some way. And you're constantly reviewing your processes and trying to reduce the waste. The lean is focused on creating a culture of respect, creating a culture where there was genuine respect between the management and the workers within a manufacturing plant. The workers were given a great level of responsibility. If you were working in a Toyota plant and you're a worker on the manufacturing line, if you saw some sort of defect in a part on the line, then you could pull a cord, and by pulling that cord, you could stop the entire manufacturing line. Now, if you stop the manufacturing line in an auto assembly plant, that's a really expensive event. But for organizations like Toyota that were practicing lean, they recognized that their focus had to be on improving product quality and reducing waste and eliminating errors and finding the source of errors in their manufacturing process. And so if they stopped the manufacturing line, the workers and managers would swarm together and collaborate to try to figure out what the source of the problem was. And they would do this over and over and over again until over time they would be, stopping the manufacturing line less and less because the quality improved. The source of errors was decreasing. This process is a process of continuous improvement. It's something that Lean calls Kaizen. And what we've learned over time is that These same sort of processes, the same philosophy that's embraced by the lean community also applies to our IT organizations. Now, we might not be manufacturing physical components like cars, but we are in the business of manufacturing code and manufacturing applications. And we are just as concerned about quality during that manufacturing process. So we can use these processes from lean, processes focused on continuous improvement, the respect for people, this idea of trying to reduce waste and improve automation. Uh, these ideas heavily inform our DevOps culture and practices. One of the key practices within lean in terms of continuous improvement is this idea that we really, if we're going to continuously improve a process, we we have to focus on improving the constraint, the bottleneck within our process. And this is what we call the theory of constraints. It was developed by Eli Goldratt. And what he said was that you can really think of any process as a chain of links. And if you focus your time and effort on improving the strongest links in that chain, then you're not really strengthening the overall chain, because the strength of your chain is ultimately going to be determined by its weakest link. And so instead of focusing your time and effort on the strong links of the chain, you should be focused on the weakest link first, which makes a lot of sense, right? If you're going to improve some sort of process within your organization, you would want to identify the constraint, identify the bottleneck within that process. If you want to improve the velocity of that process, if you want to improve the throughput of that process, if we focus our time and effort on improving the steps that are upstream of the bottleneck within our process, then then the throughput of our process will never improve, because the throughput is ultimately governed by the bottleneck in our process. And then if we focus on improving the downstream steps in our process, we're really not going to be improving the throughput either, because again, that throughput is really constrained by this bottleneck. So if you're going to improve a process, if you're going to implement continuous improvement, and you're trying to improve a process in your IT organization, you should be constantly trying to identify and think about, well, what is the constraint in this process? What is the bottleneck? Focus your time and effort on eliminating or reducing that bottleneck. Here's a very simplistic example. You might have a scenario in your organization where you're writing application code and testing it, and you want to release that code into a production environment. Now, it might take you 40 hours of effort to test a new application release. And once you've completed the testing of that release, and the testing was successful, it only takes you about 10 minutes to deploy that new software code. Well, if you wanted to improve the velocity of your service deployments, if you wanted to improve the velocity of your service lifecycle, are you going to focus your time and effort on improving the deployment process when that deployment process only takes you 10 minutes? The testing process takes you 40 hours. So that's really the constraint. If your goal is to reduce your cycle time from 40 hours and 10 minutes to, like 2 hours, then you need to be investing your time and effort on improving the testing process. And this isn't necessarily meant to be like a real world scenario, but you'd be surprised, how often I see organizations, they're spending a lot of time and effort on steps within their life cycle that are really not currently constraints. And the steps that are constraints, like oftentimes it's testing, um, they're not putting a lot of time and effort into improving those steps. Another concept that you need to understand uh, about lean is how work progresses through a a a through an organization um, that is practicing lean. And there's this whole set of knowledge that's called lean queuing theory that tries to answer this question of, what happens when we try to push work through a complex system, when we try to push work through our organization. You can think of your IT organization, think of your software development teams. That's a complex system. There are dozens or maybe hundreds of people involved. There are all kinds of different work queues. There are, different queues of stories and backlogs, and we have different iterations. We're trying to push work through this very complex system. And what's the best way to push work through that system? That's what lean queuing theory tries to help us understand. Well, traditionally, when we thought about, how do we push work through a complex system, we would focus on what we call utilization thinking. The idea was that in order to push work through our organization, we had to focus on operating all of our organizational resources at peak capacity, meaning that we had to make sure that all of our workers, all of our developers were coding at nearly 100% capacity. And we would try to sort of optimize work locally rather than looking at work from a system level. Optimize work locally, meaning that we would try to make sure that every developer within our organization, they were sort of had full capacity, and we're trying to schedule our work and shift it around and engage in all these planning exercises to make sure that everyone is operating at peak performance. That's the traditional utilization thinking. Another way of looking at it, and this is the way that lean looks at it, is that organizations, instead of thinking about how do we make sure that all of our resources are operating at peak capacity, our organization should really be thinking about overall throughput of work. In other words, we're putting work into the system, and how can we how can we how can we ensure that we're sort of optimizing the flow of that work through the system and getting the most output that we possibly can. So in order to do that, instead of focusing on individual workers, individual resources within the system, and making sure that they're operating at peak capacity, we try to identify constraints within our system, within our organization. We try to figure out, well, what are the things that are constraining work? What are the things that are slowing work down as it progresses through our organization? And this this focus on throughput has led to a different way of thinking about how we sort of manage work within our complex system. When you think of software development organizations in terms of queuing theory are considered what we call a stochastic system with queues, meaning that essentially this means that software development teams are sort of non-linear, non-deterministic. Work is pushed into these teams, but there's no way to really understand or predict exactly how work is going to progress through the software development teams and get out. There are just too many variables involved. There are too many random events. There are too many unknown factors which impact that work as it progresses through the development organization. And what we've found over time and what lean queuing theory has taught us is that the behavior of these types of systems, these software development organizations, really defies our natural instincts. You know, traditionally, we would try to push as much work as we possibly could into the development organization. So we would sort of increase the batch sizes of the work that we were doing. We were working on big projects, and we would work on these projects for months, sometimes years at a time. But what we found was that these large projects actually actually created more variability within the flow of work within our development organizations. We found that that work was queuing up in more areas within the organization. And traditionally our natural instinct was that, well, because we have more work that we're trying to produce, we just need to improve worker utilization. We just need to make our software developers work harder. And that will make the work flow faster through the system. But what we found in queuing theory was that it actually made it worse. Increasing our worker utilization, taking our software developers and moving them from 80% utilized to 95% utilized actually slow down the work, actually increase the queuing of work within this very complex software development system. And so without getting into many of the details of queuing theory, what has come out of this queuing theory is something that we call Little's Law. And what Little's Law says is, and this has been mathematically proven. What Little's Law says is that if you're working within one of these stochastic systems, one of these nonlinear, non-deterministic systems like a software development organization, the only way to maximize the throughput of work through that type of system is by minimizing the amount of work in progress in the system at any given point in time. And you can minimize the amount of work in progress through that system by using small batch sizes. So what does that mean in plain English? That means that instead of trying to push a large volume of work into a very complex software development organization, you need to break up that large amount of work into very, very small pieces. And as small of pieces as possible. And instead of pushing all that work through the system, you're pushing small pieces of work through the system. And then overall, and over time, that will actually, you'll see better throughput of work through the system because you're working on smaller batch sizes of work. And this is really fundamental to practices like agile software development. In agile software development, we focus on short sprints, right? Or short iterations of work. And when we're doing these short iterations of work, we're working on small stories and small features of work. We're trying to get that work done within our iteration, and after each iteration, we learn, and we take the learning from and we take that feedback from the learning, and we use it to inform the future work that we're going to do in future iterations. But everything is done in small units of work, small batch sizes over many iterations. And the reason for that again is because of Little's law. Little's law tells us that the only way we can maximize throughput, the throughput of work in our development organization, is by minimizing the work in progress, by utilizing small batches of work. At the end of the day, within a DevOps organization, we're really not focused on building software. We're really focused on building services and managing a service lifecycle, which encompasses not just the the building and development of software application, but the maintenance and the monitoring, the deployment and the release of that software application. So it's a fundamental change in thinking from, hey, we just need to write code and test our code to, our software isn't done until it's in the hands of our customers. Our code isn't finished until our customers can begin exercising it. And even then, we still need to maintain our code and monitor our code and improve it over time. So the service lifecycle traditionally was partitioned into sort of two different phases. The first phase of the service lifecycle involved things like identifying business requirements and software technology requirements, modeling and matching those requirements to some sort of architecture and framework, and then building and composing the application code. And this part of the service lifecycle is what I call developer land. This is the area that software developers were mostly focused on. They were over there in a different floor of the building or a different part of the floor in their own world, thinking of code and features and building stuff. Then they would throw it over the wall, and the operations team would take care of the other half of the service lifecycle. The operations team would provision infrastructure. They might have to integrate and figure out how to deploy different parts of the application platform to that infrastructure. They would be concerned with the security and the reliability of the application. and then they would have to evaluate and monitor the health and performance of the application over time. And this was operations land. The developers didn't go into operations land all that often. The operations people really weren't all that involved in development. In a DevOps organization, the focus of both developers and operations people is on service delivery because both teams are ultimately accountable for service delivery. While developers might be focused on earlier phases of the software delivery lifecycle, like the coding and the building of applications, developers are still responsible, are still involved in the latter stages, and vice versa. The operations people, while much of their time and attention might be focused on the deployment and monitoring of applications, the operations people are are still involved in the earlier phases of the service delivery lifecycle in a DevOps organization. Well, how do they do that? How do we shift from this organization that, where it's clearly partitioned and you have developer land and operations land to an organization where both teams are accountable for the service delivery? Well, one way to do that is a practice that we call design for operations. And one of the fundamental problems that you run into oftentimes when you're developing applications is that in the early software development phase, when you're trying to identify the features and technologies and frameworks and so on, oftentimes developers are not accounting for deployment concerns. They're not accounting for operational concerns like how do we how do we build, how do we deploy this application, this code in a fault tolerant manner? How do we back up this application code? How do we audit this code? How do we audit, this feature? How do we ensure that it's secure? And so all of these sort of non-functional operational requirements oftentimes get lost or forgotten in the early stages of the software or service lifecycle. So in a DevOps organization, we we follow this sort of design for operations practice where operations staff members participate in software planning discussions. Operations people are engaged in those initial discussions to ensure that these non-functional requirements are a part of the initial software design. And these non-functional requirements, oftentimes we call them the ilities. We're talking about things like availability, scalability, supportability, testability, etc. We make sure that we're having those conversations with the development teams early on in the service delivery lifecycle. Well, so the operations team members are participating on a regular basis in the development team meetings. The the developers also have a role to play. And in an organization that's embraced these DevOps practices, the developers are participating in service delivery and support. The developers are just as accountable for the delivery of the service that they're coding as the operations team members are. The idea is that you sort of eat your own dog food. If your developers are writing really crappy code, then they might get a call at 3 a.m. in the morning, and they might get a page from the application monitoring and alerting system saying that there's a problem with the code they wrote. There's a problem with the feature that they built. So the developers are on the front lines supporting service delivery just as much as the operations people are. And this makes a lot of sense to me because I can speak. I mean, most of my career has been spent on the more on the operations side, and oftentimes we're tasked with having to support an application where we didn't write the code, so we don't really know how the application works under the hood. Whereas the developers, they might have intimate knowledge of the code and be able to identify and troubleshoot and resolve issues much more quickly than someone on the operations team. So by having joint accountability for the service, they're able to produce a service that is higher quality because they both have accountability. Now, you might be asking yourself the question, if developers are now responsible for supporting a service in production, does that mean that I have to give my developers root access to systems? Do they have to have administrative access? That's not necessarily the case. I think that developers need to have enough access to systems so that they can troubleshoot problems that pop up. That level of access, maybe it is administrative access. Oftentimes it's not necessary to provide that because you can give them access to application logs, you can give them access to monitoring dashboards and metrics, and they can use this information to push out new code changes that correct whatever problem is being experienced in a production environment. So just because you're working on an operations team and you're working side by side with a development team to deliver a service doesn't necessarily mean that everybody has full administrative access to all of the different infrastructure resources that are powering the application in the production environment. I mentioned that transparency is a really important characteristic of the culture in a DevOps organization. And in organizations that have embraced DevOps, the staff members are empowered to improve quality. This again is one of those key lean principles. I mentioned the Toyota production line where any worker on the line is empowered to stop the production line at any time they see some sort of quality issue. And when the production line stops, then everybody works together. It's a collaborative activity where both the management team members and the workers are involved in trying to solve the quality problem. And that becomes the highest priority job for that particular team. The same is true within our IT organizations. We need to empower our team members to improve quality. We do that through, by creating an organization that's very transparent, where everyone is free to speak their mind and point out quality issues. Anytime we have a service issue, we address those service issues at post-mortem meetings. And these are meetings that we schedule no later than 48 hours after some sort of service incident. And during these post-mortem meetings, we're focused on trying to determine the root cause of the problem. We're not trying to figure out who to blame, who made a mistake. And whatever corrective action comes out of this meeting, we make that really the highest priority. We're focused on continuous improvement. We're focused on identifying the issues that are impacting the quality of our service, and we're using a we're embracing collaboration and transparency to sort of mitigate those quality issues. It turns out that a a a, a culture and an organization which has embraced a blameless environment is an environment that's actually safer for employees. It's a environment where employees feel happier, they feel more empowered. Employees are more willing to participate in discussions. They're more willing to share risks, with their teammates and with the management team. Um, an organization that embraces a blameless environment is an organization where employees won't hide mistakes. That's a real danger, by the way. If you work in an organization where people are punished for their mistakes, then what will happen over time is that the employees will begin to fear punishment. They'll begin to fear, the possibility of losing their job. And so instead of surfacing mistakes and surfacing risks, they will begin to hide mistakes and errors that they're making. And that'll prevent the organization from having the opportunity to improve service quality. An organization that embraces transparency is an organization that is more willing to experiment and take risks and test out different ways to improve services. And I think experimentation is really important. Experimentation is a way for us to evaluate the risks of our potential decisions in advance and to make really informed decisions that will have an impact on our service delivery. So the third component of a DevOps culture that I talked about earlier was this notion that that a DevOps culture is a culture which embraces change. It's a culture that recognizes that change is inevitable in any organization, that change represents progress, that organizations have to evolve over time, that products and applications and our code needs to change as the needs of our customers changes. The software development practices that we implement, like lean and agile software development, are designed to help us focus on creating smaller batch sizes of work and ultimately increasing the rate of change within our organization. Because remember, the only way we can maximize the throughput of work through our organization is by limiting the amount of work in progress through smaller batch sizes, through smaller uh, pieces of work. That's how we can increase the rate of change within the organization. And it turns out that, the more we change within our organization, the better we get at it. I look at it sort of like a sports team. Imagine you could assemble an NBA basketball team, and you were able to recruit the best players in the league at any given position. But that team, that this sort of superstar team, was only able to practice together once every 3 months. Would that team be able to win a championship? It's pretty unlikely. I mean, even the best athletes in the world have to continuously practice. They're building that muscle memory. They're trying to, ensure that their skills don't atrophy or get stale. You see an athlete that's injured, and usually when they're coming off of an injury and they haven't been playing for maybe several weeks, they're a little bit rusty, right? Because they just haven't been practicing. They're not in the flow of things. The same is true within our IT organizations. If we want to get better at deploying our code and releasing our applications code, then we have to do it more often. We have to practice more often. We can't expect to be we can't expect to be really good at deploying our code if we only deploy it once a quarter, because we just don't practice it enough. We don't get the opportunity. We'll never get good at it. But if we're deploying code every week or maybe every day or every hour, then we're going to get really good at deploying code because we're practicing it so often. So in a DevOps organization, we embrace change, and we're focused on trying to figure out, how do we change more frequently? How do we go from deploying code every month to deploying code every week to deploying code every day to every hour? And how do we push changes? How do we push code changes at any time of day without impacting the health of our services? Companies like Amazon and Netflix deploy application code changes to production thousands of times a day. Amazon pushes a change to production, like, more than less than every 11 seconds. So thousands and thousands of times a day. On the other hand, many companies that I've consulted with over the past few years are still stuck in a cycle where they're releasing and they're deploying code into their production environments once a quarter or once every 6 months. And they're struggling to figure out why they're having so many problems deploying their code. Why is it the case when they deploy their code that there's so many defects, that there are times when they have to revert those code changes and restore data? Why are they encountering those problems? And I think it to you by now it should be pretty clear to you that, if you're deploying your code into your production environment once every 3 or 4 months, you're never going to get good at it. You're just simply not practicing it enough. Now, you might be asking yourself the question, well, Jason, my organization, there's no way we can deploy code all that often. We can't make changes to our code base in the middle of the day. There are certain things like, database schema changes that just simply cannot happen in the middle of the day. We need to make these changes during a maintenance window because we have no choice but to disrupt our service delivery and potentially impact our customers. Well, it's true that many of our legacy applications were designed in such a way that if we were to try to make database changes, that we would impact the service. But if we're working on a modern application, or if we're designing a new application, we can design that application with a zero downtime deployment strategy in mind. And there are ways to design our application and design our databases so that we can make database schema changes in the middle of the day without impacting our service, without having to take down our service and put it in maintenance mode. Now, these database schema changes might require multiple steps. We might not be able to push out a schema change in one step. It might entail two or three different steps over time. And there's a whole set of processes around this zero downtime deployment strategy that we call evolutionary database design. We can evolve our database schema over time to meet whatever requirements that we have. What I find is that when you present software developers with these ideas of evolutionary database design with implementing zero downtime development or deployment strategies, the software developers will look at it and they'll say, well, yeah, this is true. I could deploy changes in a way to eliminate service downtime, and I could evolve my database schema over time by pushing out changes in multiple phases, but that just takes too long. And since my organization, if I'm a software developer and my organization deploys changes once a quarter, then I'm not going to wait 3 quarters to evolve my database schema. I just want to push all those changes out all at once. So many traditional organizations they struggle with this idea of a zero downtime deployment strategy simply because they deploy new code to their production environments so infrequently that it just it doesn't make sense to them. But an organization that is able to deploy to production every day or every hour of every day, they can stage those code changes in such a way as to uh, virtually eliminate service downtime for their customers, meaning that they can now push out changes to their production environment at any time of the day. They don't have to wait to make changes at a really inconvenient hour of the day. They don't have to force their software developers to be up at 3 a.m. in the morning pushing code changes and trying to fix issues. They can push those code changes in the middle of the day when their software developers are awake and active.